Find the domain of the following functions. Then write your final answers in interval notation. And here we are given two rational functions. So to begin, let's recall that rational functions do not exist if their denominator is equal to 0. So to find the domain of a rational function, we want to be sure to set that denominator not equal to 0 and solve for x. We will then exclude any of these undefined x values from our domain. So in part A, we are asked to find the domain of the rational function f of x is equal to x minus 4, all divided by x squared plus 8x plus 16. So to find the domain of this rational function, we need to set our denominator, which here is x squared plus 8x plus 16, not equal to 0. And now we want to go ahead and solve for x. So to solve for x, we need to factor this quadratic expression. And we can rewrite this as x plus 4 multiplied by x plus 4 is not equal to 0. So we can now solve each one of these binomials for x. So notice our binomials here, x plus 4, are matching. So what we find in the first case is going to follow through to our second case. So considering case 1, we have x plus 4 cannot be equal to 0. So to isolate x, we are going to subtract this 4 from both sides of the expression. And we can see 4 minus 4, they cancel out to 0, showing us here that x cannot be equal to negative 4. So what we have found is that x can be any real number our little hearts desire, except negative 4. So to find this in interval notation, we can start here by simply thinking about our x number line. And we'll say right about there, there's negative 4. So we want to make sure that we exclude this value. So we draw an open hole or open circle at this point. So from here, we know that x can be anything greater than negative 4, moving in that infinitely positive direction. We also know that x could be anything less than negative 4, moving in that infinitely negative direction. So we can use our number line here to write the interval notation for our domain. We can say that x is an element of the interval from negative infinity up into negative 4. And now we know x cannot equal negative 4, so we use a round or open parentheses at this value. And on the other side of negative 4, we have the similar idea. X could be anything strictly greater than negative 4, moving in that infinitely positive direction. So then last but not least, we need to unite these two intervals using our union symbol. So there you have it. This is our domain in interval notation for part A. Now, in part B, we apply a similar technique to find the domain of the rational function g of x is equal to x divided by x squared plus 36. So again, we know that with a rational function, we need to exclude any values of x that make the denominator 0. So to begin, we are going to set our denominator, x squared plus 36, not equal to 0, and solve for x. So here, there's no need to factor. We can immediately begin to isolate this x squared, and we can subtract this 36 from both sides of the equation. And again, we see 36 minus 36. Those terms cancel each other out to 0, showing us that x squared cannot be equal to negative 36. Now, wait a second. We know that x squared is always going to produce a positive value. And we know this because when we multiply a negative number by another negative number, we produce a positive value. So therefore, since x squared is never negative, there are no values of x that will make x squared equal negative 36. So this means that there are no restrictions on the domain. So we can say that our domain for this function is the set of all reals. And in interval notation, we would say that x is an element of the interval from negative infinity to positive infinity, making this our beautiful final answer.